Next, we're going to look at a special type of relation called a function. Now, a function is a relation in which each possible input value leads to only one of the output values. Again, a function is a relation in which each possible input value leads to only one of the output values, but not more. So to illustrate that, let's go back to the relation that we saw before, matching the superheroes to their secret identities. Now, each superhero only has one secret identity. Superman is Clark Kent, Batman is also Bruce Wayne, Spider-Man is Peter Parker. No superhero has more than one secret identity. It's not the case that Superman is both Clark Kent and Peter Parker. So because each input value, in this case, the identity of the superhero, is matched to only one output value, in this case, the identity or their secret identity, this relation is a function. Okay? Because there's only one output value for any one input value. Let's take a look at some more examples. On the left, you'll see examples of functions, and on the right, you'll see examples that are not functions. So take a look at this mapping diagram on the left. We've got two arrows pointing to one thing, so we have one output that corresponds to two inputs. But that's okay, because there's no input leading to two outputs. Contrast that with this scenario over here. Here, we have an input of 1 on the left going to an output of 4 and an output of 5. So there's one input leading to more than one, in this case 2 outputs. So this is not a function. Think of you being trying to be the matching rule. You're sitting in here and trying to decide what to do. If someone hands you a 1, in this case, you have to choose. Do you hand back a 4 or a 5 as an output? It's not clear. Whereas here on the left, if they hand you a 1, you know you hand back a 4. And if they hand you a 2, you know to hand back a 4 as well. Even though you're handing back a 4 in both cases as the output, you never have to choose. It's always clear. Whereas here, if you are given a 1 as an input, it's not clear which one to choose. So because you have that choice, because there's more than one output, that makes this not a function, whereas this is a function. Take a look when we write in ordered pairs. As an ordered pair, if there is ever one input, that's one leftmost or left side x value that has more than one right side or y value, then it's not a function. So here, even though all of 3, 5, and 1 are leading to outputs of 4, that's okay. It's a situation kind of like this. Contrast that with this situation. Here, an input of 1 is leading to an output of 4, but an input of 1 is also leading to an output of 3. So there's one input that has more than one output. That makes it not a function. If we were to look at a graph, remember that on a graph, we move across in the x dimension to get an input and up in the y dimension to find the corresponding output. In this case, there's no way you can move across and then have to choose whether what your output is, moving up or down. Every time you move across, it's clear what the output is. Contrast that with the situation on the right here. If you are to move to any point on the right here, you're always stuck with a choice. Say I go to what this looks like about 1 point or 1 1/4 that I've drawn an arrow to. At 1 1/4, the output could be, well, it looks like a little bit over 1, or it could be a little bit less than -1. I've got 2 possible outputs for one input, so that makes this not a function. Whereas on the left-hand side, we never have that problem. Any input I put in, any horizontal distance I move, it's always clear what vertical distance I have to move to get to the graph. And I'll give you a rule in the next video for looking at graphs and how to, a quick rule for remembering that. So remember that all functions are relations. A relation is just a mapping rule, and a function is a mapping rule that has only one output for any one input. So all functions are relations, but not all relations are functions, and that's shown down here in the diagram. Functions are a subset of relations.